Greetings, everyone. The quiz 14 will be on game trees, and I will look at two different games in this review, two games that we have already encountered. So just go over one more example. I'll take a little bit more complicated ones. So let's start with the NIM game, where our starting condition is two piles of size 3. Okay, so that becomes our node 3, 3. And then what can we do? Well, it's symmetrical. So again, symmetric things we won't consider, right? So we can take 1 away from one of the piles. That would be a 2, 3 pile. So I'm going to put that here. I could take 2 away. That's a 1, 3 pile. Or I could take all 3 away, and these are the 3 combinations that we have. Okay. Next, 2, 3. What can we do? Well, we can take 1 away. That is a 1, 3 from the first pile, or we can take the whole pile away, and that's a 3. Okay, so there are 2 possibilities. That's not everything, because now I can play with the second pile. I can take 1 away. That's a 2, 2. I could also take 2 away. That would be 2, 1, 1, 2. I'm going to put this over here. Or I could take even all 3 away and have a 2, which I'm going to put here. Doesn't matter where I put these things. These are not ordered trees for us. Okay, then 1, 3. In 1, 3, I can take the 1 away and have a 3. Now I have already a vertex on this level, so this is important. Vertices are these labels are game situations, the present situation that the player is confronting, right? And that he is, this is the board on which he has to play, if you want. And they are on a particular level. And it doesn't matter what their parents are, the value that they will have in this tree, when we calculate the weight or the value of that node or that vertex, will always be the same. So there is no point in duplicating a node, a vertex, if it's on the same level. If it's on different levels, you will see they will get different values, so that we cannot combine those. So what I mean to say is, technically we should have a new vertex that goes from here to a vertex labeled 3. But to not overload our notation, I'm just gonna reuse one of the vertices, and I'll indicate this with like, let me not even do dotted line. Let me just do full line. It doesn't matter. So the colors here mean that some of these edges are not really edges in the tree. They should have been. They are copies, right? Because this is no longer a tree as it stands. But it just is easier for me to keep track of everything. Okay, so that's one taking, and also to not overload the situation. And so please do that too, because if you're going to make notes for every single child, you're going to have at the end so many that you cannot see anymore what the parents are and how it gets together. So I'm using different colors here for me to visually see what is going on here. So what are the children of 1, 3? 3 is a child. Now at the second pile I can take 1 away. That would be a 1, 2, which is also something I have. I can take 2 away. There was a 1, 1, which I don't have, so I'll make a new note for that. Well, perhaps I should, okay, that doesn't matter what color I use. 1, 1. Or I could take all 3 away and then I have a 1 node. Okay, I'm going to put that one here. I still have a little bit of space here. 1. Again, where I put them doesn't matter, but it's very important that you don't forget any, because that might be the winning/losing position. Okay, so that's for 1, 3. What about the 3? Well, I can take 1 away and that gives me 2, so that would actually something that I have already. I can take 2 away, that gives me 1. Or I can take all away and that gives me 0. So that's a node that I don't have yet at that level. Okay, that takes care of this level. Next level. Okay, 1, 3, what can I do? Well, I can take the 1 away, so that would give me a 3. I'm going to put that here. I can take from the second pile 1 away, that would be a 1, 2. Take 2 away, 1, 1, or take the whole thing away, and that would be a 1. Let's put that here. Okay, now with the 2 pile, I'm trying to use different colors. You'll see that how it helps me. A 2 pile, I can take either one of them away or both of them. Yeah, so I don't want to go too crooked, so I'm going to put my 0 here. Okay. The 3 pile, I can take one away, that would give me a 2, so I still have a split. Oh no, let me do a different color, otherwise I'm going to get confused later. I'm going to use this one. So I can take 1 away, that gives me 2. I can take 2 away, that gives me 1, or I can take all 3 away, that gives me 0. Alright. The 1 pile, there's only one thing I can do, that is taking that away. So that goes that. The 2 pile, I can make it into a 1 2. So this would be a 1 2. Or I take the whole first pile away and I get a 2. So it is this one. And that's it, right? Can I do anything else? I take 1 away, I take 2 away. No, that's it. Okay, that's easy. The 1 2 pile, what can I do there? I'm running a little bit out of colors, so let's make this in blue. The 1 2, I can take a 1 away, that gives me a 2. Oh, I didn't change the color. Okay. 2. If I take the first pile away, if I take one of the first, that gives me a 1 1. Or I take the whole thing away, I get a 1. You see why I'm saying there's so many duplicates that you see there's a lot of edges, right? And it's very hard to see what comes from where, but hopefully the coloring will help us a little bit. And then the 1 1, so yeah, more colors required, guys. Okay, so let's do purple. From 1 1, well, there's actually only one thing you can do from 1 1, that is taking one of those piles away, so that is easy. And from 0, of course, that's the end of this, that's the leaf. Okay, that takes care of that level. So now here we can take 1 away, we can take 2 away, or we can take all 3 away. 0. Okay. The 1 2, I can take the first one away, that would give me that. I can take one of the second ones away, that will be a 1 1. I'll put that here. Or I can take the whole second pile away and I would end up here. Okay, 0 is a leaf. 1 1, there's only one thing you can do with the 1 1, is take one of these piles away and you end up here. The 1 pile, there's only one thing you can do, that is just take that guy away. That's 0 here. And then the 2 pile, okay, there you can go either to 1 or 0. Okay, we are getting much less and less traffic, if you honestly think of it like that way. We can take 1 away, or we can take 2 away, so that's 1 and 0. For the 1 pile, that's only one thing we can do here, that is 0. The 1 1 pile, only one thing we can do, that is go there. And the 0 pile is a leaf, so also that is gone, so we are there after this last step. Alright, so where are we level-wise? It's of course very important that we do everything always in levels, right? And then this is max, min, max, min, max, min, max. Okay, and whether we can just see can we win or lose, or we can do with the payoff. And of course, if you do it with the payoff, if you have a positive amount, then you will be able to win. And if you do a negative amount, you will lose. If the other player is smart and not smart enough to counter any of your acts. So let's do the payoff game. That gives all the information that we want, and the payoff for our purposes is going to be just the level 0, 1, 2, 3, 4, 5, 6. You could devise different kinds of payoffs, of course, but okay, we will for this one. Okay, so here we are. Let's write our start calculating the weights. Now the bottom in level 6, this max's level, if he confronts there with a 0 pile, he's losing, right? And so this would cost him $6. Oh, that's too big. What do I do here? we do it with this one here. Okay, so this is, no, that's too light. This is, that's still too light. Oh, what is going on here? Sorry guys, I just want to make it okay, legible enough. -6. No, what is this? What do I make this? -6. What is with my blues? Okay, where's my nice blue? Anyways, okay, -6. Next level, well, previous level, level 5. Okay, this one is a child, as only inherits from a child. We have to take the minimum, but it is only one child. And here the 0 is a leaf. It's in the losing, its min is losing, so it's a win for max, so that will be 5, value 5. Okay, level 4, that is again losing for max, so that will be a -4 here. Okay, so what about the other ones? 2. We are in the max level, so we have to take the max of the parents of this guy. Sorry, the children of this guy. This guy has -6 child and 5 child. The maximum is a 5, so that is good news. We're supporting for a max, right? Okay, so max gets the good thing. What about the one here? Well, it just inherits from its parents, so there's also 5. The 1 inherits from its child. 1 inherits from the child, that is -6. And the 0 we already said. Okay, in the next level there's a 0 here, so this will have value 3. Okay, what's the value of 3? It's a min, so we have to look at all the children of 3, the black ones, okay, and take the minimum. That is 5, 5, and -4. So that is -4. -4. 1, 2. We have to take minimum, and the children have value. Now we following the red edges. That is 5, 5, and -6. Oh damn, that is -6. 0 we have already got. 1, it's just inherits from a child, and that gets a value 5. Okay, the 1 inherits from a child, that is -4, and the 2 we have to take the min between. One child has value 5 and the other has -4, so the min will be -4. Okay. Level 2. Max, okay, max, you should want to be here, so this will be -2. And then I'll just do the leaves first so that I don't forget them. No, let's go back to the left here. 1, 3. We are in the max situation, so we look at all the children of 1, 3, which are 4 of them, and we take the maximum of the possibilities, and that is maximum of -4, -6, 5, and -4. So that is actually 5. Okay. 2 has 2 children with weights 3 and -4, right? Yes, so the maximum is 3. Okay. 3 has how many children? 3 has 3 children. 1 has value 3, 1 has value -4, and the other one has -4. Well, we take maximum, so that is also 3. 1 inherits from a child, which is value 3. Okay, so the value is 3 here. Then 2, 2. 2, 2 has only 2 children, so it inherits, it's -6 one child, and the other child is -4, so the maximum is -4. 1, 2, 3 children, 5, -4, -4, so the maximum is 5. 1, 1 is 1 child, and that value is -4. Right, okay, and we got everything, all right, min, we're almost there. 1, 2, 3, 4, 5, 2, 3 has 5 children, and we have to take the minimum of their values. That is minimum of 5, 3, 3, -4, and 5, right? Yeah. So that would be -4. Yeah, pity, huh? 1, 3. We have 3, 3, 5, and -4. Not good, not looking good, Max. And 3 has values. So this one here. Okay, so we have 3 here. a 3 here and a -2. That is -2. We were doing this in blue, right? -2. So finally, the max of this whole thing is -2. So he's gonna lose in this game, and he can minimize his cost by what to do. So how does he have to play? Green is max, right? So let's see what Max should do. Max has to play this. Sorry, I want to make this a bit bigger now. So Max should be this, because that's his best case scenario. And now it depends a little bit of what Min is doing. Now, of course, in this particular game, it takes everything away, and then it would be silly not to see this, okay? But if somehow he's not paying attention and he plays this, now all of a sudden Max has a chance. No, now Max can win. What should make well, that's also, again, sorry, let me say he chooses to do this, okay? He makes this choice. And now Max has a winning strategy. What he should do, well, take everything away and he gets to a 0 here, okay? Okay, so that's the Nim game. The 3-3 game is not too exciting, I guess. So I want to do another one with the matches. So take away matches from a pile, and if you cannot do it anymore, you lose, right? And so let's take away 3, 4, and 10. These are the amounts that you can take away. So I'm changing that part of the game. I'm taking different amounts that you can take away, 3, 4, and 10. And let's start with 20. So we start here with 20. Okay. And the payoff will be, so what are the leaves? Let's discuss what are the leaves going to be. Well, anything that is smaller than any of these numbers, right? So 0, 1, and 2. Okay. So I'm okay. The payoff will be this. If you cannot play, you lose. And what you pay, so you pay the level plus twice the number of matches left. Okay. Now this is something we'll figure it out later. But let's just draw the tree now. Okay, 20. There are 3 possibilities. You can go either take 3 away, you take 4 away, or you take 10 away. Okay. So now, okay, next level from 17, you can take 3 away. That's going to give you 14. Why don't we go that deep? I should go not that deep. Let's go this way. So take 3 away, take 4 away, or take 10 away. So again, losing different colors. For 16, I can take 3 away. I can take 4 away. That would give me 12, right? So I don't have 12 yet. It doesn't matter where I put it, here. Or I can take 10 away. That's just 6. So I'll put that somewhere here. Okay. And then for 10, what can I do there? I can take 3 away. That will give me 7. I can take 4 away. That gives me 6. Or I can take all 10 away, and that gives me 0. Okay, next level. In 14, I can take 3 away, that would be 11. 4 would be 10. And 10 away would be 4. Let's put that somewhere here. 13, I can take 3 away. 4, that would be 9. Or 10 of them, that would be 3 here. Okay, 7. In 7, I can take 3 away, that is 4. I can take 4 away, that is 3. And I cannot take 10 away, so that's it. 12. In 12, I can take 3 away, that would be this. Oh, this is, I knew it was bubbles. No bubblies here, guys. We want small guys and straight guys. Okay. So, what was I doing? 12, I take 3 away. I take 4 away, that's 8. I don't have 8 yet. Okay, let's put 8 somewhere here. Or I can take 10 away, then I have 2. Okay, 6. In 6, I can take 3 away, that would give me 3. I can take 4 away, that gives me this. And I cannot take 0 away. And 0, of course, is a leaf. Okay, that's that level. 11, I can take 3 away, that would be 8. I can take 4 away, that would be 7, or I can take even all away, and that would be 10 away, and that would be 1. 10, I take 3 away, 4, I don't have that yet, or all 10, and that would be 0. Let's put that here. 9, even 9, I can take 3, 4, which I don't, that would give me 5, and I cannot take 10 away. From 4, I can only do 1, I can take, oh no, 2 things, I can take either 3 away or 4 away, so 2 possibilities here. Okay, 8, I can take 3 away, 4 away, 4, I don't have 4 yet, okay, let me put 4 here, and that's it. From 3, I'm running out of pop color, so let's make this gray. From 3, what can I do? Well, there's only one thing I can do, that is that. Take 3 away. And 2 is already a leaf. Okay, good, we're getting. You see, it goes down relatively quick. We can take 3 away, this would be 5. We can take 4 away, that would be 4, and that's it. From 7, we can take 3 away, or we can take 4 away, that would be 3. From 6, we can take 3 away, or 4. From 5, we can take 3 away, or 4 away. And 1, of course, is a leaf. 4, we can do 2 things. From 4, we can take 3 away, or 4 away. 0. Okay, next level. 5. Let me go a little bit now here, because things are going to get less and less, right? So this, take 3 away, that's 2 left, or I take 2 away, that is 1 left. From 4, I can take 3 away, or everything, that's 0. And then there's only 1 more left, that is this guy. So just our leaves. Okay, so that's it, right? Everything is now leaves. Let's start calculating values now. And you see, with my new payoff, it will be a little bit different. So first of all, let's indicate the levels. Okay. Yes, so this is max, this is min, max, min, max. This is very important, right? Because this tells us how we calculate max, the values. Okay, so let's take red here to calculate all my weights, the values, the cost, the payoff, whatever you call it. So let's start with the level. Okay, we should perhaps also, this is level 0, level 1, level 2, level 3, level 4, level 5, level 6. Why are my colors so weak? I want... Is it perhaps because I'm... No? My colors have gone shady, or is it because I'm... No? I don't know why I want bright colors, but for some reason I'm not getting that. Okay, so let's now discuss what I said the payoff is. So max is losing. In this thing here, these are all losses for max, so this will be negative. So how much does he have to pay? Well, it's the level, which is 6, plus twice the number of matches left. So here are 2 matches left, so times 2, that is 4, plus 6, it's 10. So his payoff here is 10. Where is my red here? Minus 10. Minus because it's something he has to pay, right? We always think of Max's point of view. Then if there's 1 match here, then he's at level 6 plus the 1 match that will cost him 8. So the best thing for him, if he ends up in this thing, would be this one, because this would only cost him the $6. Okay, now we go to min. Let's first think about the leaves for min. If he has this level 5, so this would be he has to buy 5, so that would be for an income for max would receive 5. Max would receive 7 here, because level plus 1 twice 1 match, and here would be 9, right? There are 2 matches, 2. So the formula here is 5 plus 2 times 2. We have the level and the a number of matches, okay, and the 2 is a factor, fixed factor that I said. We can change these things as we want, right? So you see there are many variations here that we can play. Okay, so now now we have to think about the children, the parents, the internal vertices. Let's do vertex 3 here. Well, it has only one child, so we don't have to think about it. That's -6. This guy has 2 child, and we are in the min situation, so we have to take the lowest of both, that is -8, and for the vertex labeled 5, you have to take the minimum, that is -10. Why do we take the minimum? Just perhaps sometimes it's good to remind yourself, why are we taking the minimum? Because if your min, right, he can decide what to do here. It's Min's game. He can make it as bad as possible. That's why we take the minimum, right? Okay, so moving on. There are 2 leaves, so let's take care of those. These are leaves where he loses. Here he would lose $4 because that's the level, and here he would lose $6 because there's also one match. That every match is another $2. Okay, now let's go to the other ones. And I'm going, let's start on the left here. So we have 2 children, and we have to take the max of these 2. Okay, so that would be -8. 7 has 2 children, and the max of these is -6. 6 has 2 children, and the max is 9. 9? Where did 9 come from? Oh, yeah, right, 9. Wow, yeah, right. I've never seen these big payoffs because this is the first time we do this kind of high stakes match game, right? Okay, 5 has 2 children. One has value 9, that's the highest, so that's also 9. And then 4, still has this little guy left, right? 4 has 2 children, 7 and 5, the max would be 7. Okay. Next level. Now we're in the min level. There's still one leaf, that's this guy here, so that min is losing here, so this is going to be a positive number for the level is true. 3 plus 2 matches is another additional 4, so this would be an income of 7 for max. Okay, let's now go to from left to right. This guy, he has 3 children. We have to take the minimum. Values of these children are -8, -6, and -6. The minimum is -6. -8. 10 has 3 children, -6, 9, and -4. The minimum is -6. So that's not that great. 9. The minimum of that, both children have value 9, so this node has value 9. Okay. The one labeled 4, okay, I'm here in case you're not following. 2 children, -6 and -4. The minimum is -6. Sorry, remember we're in min here. Min will try to do as bad as it can make it for you. For the vertex labeled 8, it has 2 children, 9 and 7, and we have to take the minimum, so this would be 7. 3 has only 1 child, so that would be -4, and that's it. Okay, next level, this is again maxes. There's still one, max. You don't want to be in this last case here because this is going to cost you $2. Okay, now let's go to the left. 14 has 3 children. Values are -8, -6, and -6, right? So the maximum is -6. 13 has 3 children, -6, 9, and -4, so the maximum is actually 9 here. Okay. 7 has 2 children, -6 and -4, the maximum is -4. 12 has 3 children, values are 9, 7, and 7, so the maximum is 9. 6 has 2 children, -4 and 7, so the value would be 7. All right, let's see where we are now. This is going to tell us, right? We know on this level already, if there's everything negative, then it's bad for him. Okay, so 17. 17 has 3 children. Values are -6, 9, and -4. But we have to take the minimum, so that is -6. Not good. 16 has 3 children. Values are 9, 9, and 7. Oh, good news. That is 7. It's the minimum, but it is positive. So once we have a positive, we know we're going to have positive. So Max is in good shape here, but perhaps he can make even more money. Let's see. 10 has three children. -4, 7, and -2 are their values. We have to take the minimum of those, right? That is -4. And now at the final level, we take the maximum. This is 7. So Max has a strategy of winning $7 in this game. And let's try to trace it just for the sake of it. So we make a little bit bigger bubbles now. We'll make it bubbles, okay? So this is what he has to play. He has to take 4 over 4. Now, Min has 3 choices, but there's only one optimal choice for him. Is optimally he has to choose to go to this. Okay, but also this needs bubbles, bigger and bubbles. Okay, so bear in mind, if he goes to any of the other 2 children, he's going to lose even more money. This is the best he can hope for. Okay, so now what should Max do? Again, Max has really only one choice. He has to do this. If he doesn't do this, he will lose. And so he can play this. And this ends the game, actually. By doing that, so what he does is takes 4 away. It ends the game because we are on a leaf, and that's the payoff he gets. Okay. So, and of course, since we're still using rather low numbers, your predictions are not that great. You see, you don't go very deep inside the game tree, right? But you can imagine if you would play this game now, say instead of 20, you go to 40 matches and with 3, 4, and 10. It's probably much more engaging, and if you ever feel like doing this, by all means, try to figure this out. Okay, so who wins, and honestly, I have not really thought deep about it. I'm sure you can figure out in advance whether, forget about the payoff, just win or lose, whether a given amount and a certain amount of matches that you can subtract. I mean, here we can even change the number of times we can subtract things, right? Here 3 different subtractions are allowed. We could do even 4 different or 5 different subtractions, okay? And then depending on what choices you make here and the starting position, when do you win, when do you lose? Are there formulas for that? I don't know. I have not really thought about that. If somebody wants to play with these things, it's for some people this is very entertaining. I must say I like it too, so that's why I spent a little bit of time explaining these things to you. And so will be on the quiz. Either the NIM game with payoff or the match game with payoff, or perhaps a twist. Well, perhaps a twist.